Good morning, my dear students. So now I'm going to conduct the second experiment named called as damped longitudinal vibration. Okay, so in previous you studied about the damped torsional vibration, and here the second experiment name is damped longitudinal vibration. Okay, so the difference between damped torsional and damped longitudinal vibration means there we are going to use a string also to conduct the experiment. Here the longitudinal vibration means we are going to use a spring. Okay, we are going and here their oscillation is a horizontal. Here the oscillation takes place in a vertical direction. That is the main difference between damped torsional vibration and damped longitudinal vibration. Okay, so remaining setup is same. Okay, so now the aim is to determine the frequency, logarithm decrement, time period, and damping factor of a spring mass damper system that is under this longitudinal vibration. Okay, so apparatus is required same the vibration spring mass damper system, where string is there, here spring we are going to conduct. Okay, so here the diagrams are same. So it consists of a spring, so one motor, one pen, that is a sketch pen, and rotating drum, and the mass in the oil spam, that is a damper, and little that is the last one is a base. Okay, this is about the diagram setup. Okay, so how to conduct this procedure? Okay, so take the graph sheet, that is a new fresh graph sheet, okay, and fix around the drum, okay, without any wrinkle. Okay, second, once you complete fixing the graph sheet, second you move on to the check whether the sketch pen is touching to the graph sheet or not. If not touching, then you make it proper touching to that. Okay, so once you touch the graph sheet, then now pull down the mass and release the start. Okay, so before that you switch on the motor. Once you switch on the motor, again now pull down the masses and release the starting. Okay, now check the disc is kept under oil or not. Okay, so that is very important. Okay, so now the longitudinal vibration of the disc is plotted on the graph sheet automatically, so with the help of that sketch pen. Okay, so now measure the xt on the graph sheet to complete the vibration part. Okay, once you calculated the xt value, use that formula. You are going to calculate what the logarithm decrement, frequency, time period, etc. That is about your procedure, that is about your result. Okay, so here the diagram is there. The diagram, that is the lab set. This experimental setup is consist of in one spring, mass, damper, pen, rotating drum, mass, oil span, that is the base. Okay, so here the spring is attached to the pen, that is a sketch pen. That sketch pen, that is a sole normal rod, that is a normal string is that is normal. This one is attached to the a mass. That mass is kept under the oil, that is a SAE oil. Okay, so once you switch on the motor, just to give the twist moment along the vertical direction, you are going to get automatically plot on the on the graph sheet, that is vibration. Okay, so and here the observation they may give the drum diameter d is equal to 60 mm. Okay, the motor speed is normally 6 rpm, that is one rotation per 10 seconds, that is equal to 0.1 rps. Okay, rotation per second. Okay, so these are the formula you are going to use to calculate what time period is equal to t is equal to xt into 10 divided by pi d seconds. So xt is taken the value from the graph sheet what you drawn on the with the help of the by conducting experiment. Okay, so now the frequency is equal to reciprocal of time period, that is hertz. Okay, damping factor zeta is equal to delta divided by 2 pi. Logarithm decrement delta is equal to ln of x1 by x2. So these are the formula we are going to calculate with the help of taking the value of xt. Okay, so now I am going to conduct this experiment on the live, so just you listen on that video, that is the second session. Okay, so I hope you understand the main importance terms in the used under this damped longitudinal vibration. Okay, I hope you understand this, the what is the main this the experiment importance. Okay, so now I'm going to conduct how to take the reading, that is xt on a graph sheet. Okay, so that is about the second session. Okay, so I hope you understand this. Okay, now I'm going to conduct that the second live, that is second how I'm going to conduct that, how I'm going to take the reading in a on experiment. Okay, so now okay, thank you. Okay, good morning, my dear students. So now I came to conduct the third experiment. Okay, so after reading before listening that PPT, you are understand that what do you mean by vibration, what are the different types of vibration. Okay, what do you mean by damped vibration, what do you mean by torsional vibration, longitudinal vibration, what is the difference between them. Okay, so now the third experiment I am going to conduct. Here the third experiment name is damped damped longitudinal vibration. Okay, so here the damped longitudinal vibration, so we are going to use again same oil. So how the vibration occur in oil, that vibration we are going to plot on this graph sheet. Okay, so here also the main difference between the previous one and here torsional and this longitudinal means in the torsional we are going to use the string. Okay, but here we are going to use spring. So this setup is called as a spring mass damper system. Okay, so here spring will be there, the mass will be there here. Okay, so damper is considering as a oil. That may be in some other colors they may use different oil. Okay, so that is oil or water, whatever that is called as a damper oil. Okay, so here now I am going to the aim of the experiment. I am going to tell you the name of the experiment is so damped longitudinal vibration. Okay, so the aim of the experiment is to determine the angular frequency time period logarithm decrement of the what this damped longitudinal vibration. Okay, so apparatus is required is the motor is required, so spring is there, so damper is required, so this drum is required, and the main is a sketch pen and this graph. These are the required, these are the components we are going to, these are the what apparatus required to conduct this experiment. Okay, so now I am going to tell you how the experiment will going to conduct. That is the procedure. Okay, take the graph sheet. Okay, so take the graph sheet. On this graph sheet you are going to fix around the drum. Okay, so once you fix this drum, now switch on the motor. You are going to get switch on the motor, so you are going to get what here vibration occurring in the oil. Okay, so that from that we are going to take the values xt, x1, x2. From that we are going to calculate the what given aim of the, that is you are going to find the what angular frequency time period. Okay, so now I am going to tell you take the graph sheet. Okay, so I am repeating this. So in the previous case the oscillation is horizontal. Okay, that is very very important, and here the oscillation is vertical direction. That is the only difference. Okay, so longitudinal vibration means a body or a system or any shaft which will be rotated along the axis of the shaft. Such type of vibration is called as longitudinal vibration. Okay, so that is around the axis of the shaft, here along the axis of the shaft. Okay, so don't make anything. Okay, torsional means the shaft, that is a body which will be rotated around the axis of the shaft. Such type of vibrations are called as torsional vibration. Longitudinal vibration nothing but a body or a system which will be rotated along the axis of the shaft is called as damped longitudinal vibration. Okay, so damped is nothing but there is a what reduction of amplitude, that is called as undamped vibration. Okay, undamped means no reduction of amplitude. Okay, so now I am going to tell you the procedure of this third experiment. So take the graph sheet, again same procedure you follow what you are going to take in the that is what torsional vibration. Okay, so take the graph sheet, so fix this around the drum. Okay, so you are going to fixing this okay, just to fix this graph sheet. Okay, once you fix this graph sheet tightly, you are going to fix without any wrinkle. Okay, so it not be display something. Okay, it's not just this extra is there, so just to remove this. Okay, so fix this graph sheet around this drum so that it will not get any wrinkle. Okay, so that is main use. Okay, so take I will take one more graph. Okay, so this is not there, just to take the one more graph sheet. Okay, so this is the length is not proper. Okay, so take the graph sheet here, so fix this around the drum. Okay, in proper direction. Full tight. Okay, so any wrinkle. Okay, so if you fix proper means you are going to get vibration in proper direction. Okay, so here there is some tape over, so you fix this tightly. Okay, once you fix the graph sheet, so second step is at the same time you see that the sketch pen should be touches to the graph sheet middle. Okay, so not center. So now this is the sketch pen we are going to fix. Just you remove the sketch pen here, so exactly it will touches to the graph sheet. Okay, so this is about the setup of this damped longitudinal vibration. Okay, when it is touches to this graph sheet, now you switch on the motor of this experiment. Okay, so now after switching this, so okay, this is about the touches to the vibration. Okay, so this you have to turn the motor. Okay, once you switch on the motor, you see that the exactly 1 cycle should be completed. Okay, so 1 cycle should be completed means you are going to get the vibration occur in this oil. Okay, so just you wait after completing one round. So just you give the okay, now you are going to see that 1 cycle is completed. That is the 1 round is completed. After 1 round, just you do the twisting movement to this shaft. Okay, so once you do this twisting movement, you are going to get what vibration. Okay, just now I am going to do the twisting movement here. Okay, you see this this is about the what amplitude which there is vibration occur in the SAE oil. Okay. So once you getting the vibration, okay, just to remove the close this segment and remove the this graphic. Okay. So after removing this graphic, what you are going to get in this graphic is, so here this is the longitudinal vibration occur in this component. Okay. So consider, take any one cycle. From one cycle you are going to consider any one cycle. Okay. So one cycle is that is called as time period. Okay. So from this to this you are going to take, from the help of scale you are going to measure and use the calculation part. Okay. So top side is assume as x1 values and bottom is x2, and one cycle is called as considered as xt. Okay. So that value you are going to use it to find the what time period in the given aim of the experiment. Okay. So this is about what the damped torsional that is longitudinal vibration. Okay. So here so there is a lot of difference between the that is what torsional and here. So here you are going to get what we are going to use a string, and here we are going to use spring. So here you are going to use the oscillation is horizontal direction. Here you are going to use the oscillation in vertical direction. Okay. So even if you observe the both the diagram, that is both the graphic, so here the longitudinal vibration you are going to get very close. Okay. So finally you are going to get the logarithm go on decreases. Okay. So from mean position to top is called as an amplitude. Okay. So similarly the amplitude goes on decreases. Okay. So finally you are going to get that is 0. Okay. So from the graph you are going to take the value of one compute one cycle, that is xt value, top one is x1, bottom is x2. Okay. So from this value use the calculation purpose. Okay. So finally you are going to get what, the logarithm decrement time period. Okay. So this is about the what damped torsional that is longitudinal vibration with oil. Okay. So I hope you understand this, how to take the reading. Okay. So thank you very much. Okay, now after seeing that how to take the reading from the that from the experiment, that is taking the graph from the experiment, so now I am going to what doing the calculation part here. Okay, in the third session. Okay, so calculation is about the nature of graph. So here the again from consider a one cycle, that distance you consider as a time, that is a xt. Okay, so that is called as a time period. Okay, so that distance you can consider in centimeter or what meter. Okay, so from the graph consider that compute one cycle, that one cycle distance you are going to take in the while in the calculation part. Okay, so again by using the formula, so time period is equal to what, the time taken to compute one cycle. Okay, so time period formula is equal to x of t is equal to into 10 divided by pi into d. So that is d is the drum diameter they given in the observation. Xt is equal to, just to substitute value here, 1.7 or 17 centimeter or 1.7 meter. Okay, so 17 into 10 divided by pi into 60, you are going to get what, t is equal to 0.901 second. Okay, so this is that at this time period we are going to get the oscillation, number of oscillation we are going to get on the graph. Okay, so second one is the frequency is equal to what, the reciprocal of time period. Okay, so already we are going to calculate what t is equal to 0.901. okay, just to substitute that 0.901 into this equation, we are going to get what, frequency. Okay, once you calculate the frequency, automatically you are going to get what, natural frequency, because omega n is equal to 2 pi f. We know that f value. Okay, f you are going to calculate already here, f is equal to 1.108. just to substitute that f value, so you are going to get what, natural frequency is equal to 6.961. okay, so just to substitute in that equation 2 pi 1.08. okay, so once you substitute by using calculator, just to substitute, you are going to get natural frequency is equal to omega n is equal to 6.961. okay, so once you calculate the logarithm, that is what the natural frequency is, so automatically you are going to calculate this logarithm decrement. okay, so here the formula is equal to ln of, that is log is equal to x of t divided by x into x n plus t. okay, so once just to substitute here, where x of t and here nothing but x1 by x2, that is first amplitude and first maximum amplitude, second maximum amplitude. okay, so from the top and down, so from the from the graph you are going to calculate this x of t, that is x1 and x2, you are going to get 2.4 and 1.1. no, that is 2.4 in, that is nothing but the maximum amplitude. okay, from the graph, and 1.1 also is the least from that particular cycle. okay, so you are going to get what, delta is equal to 0.7801. this is about the logarithm decrement. So this is the value you are going to reduce the vibration in a graph sheet. okay, so finally it reaches to the 0. okay, so next damping factor is equal to delta is equal to delta by 2 pi. okay, so delta is equal to 0.7801 and divided by 2 pi, so you are going to get what, delta is equal to 0.124. So this is about the result of this damped torsion, that is a longitudinal vibration. Okay, so this is about the second experiment in design lab. I hope you understand. So from the here the first four experiment, so you have to remember this formula. What do you mean by time period? What do you mean by frequency? What do you mean by natural frequency? What do you mean by logarithm decrement? What do you mean by damping factor? This formula you are remember means it is very simple to conduct or to do the calculation of this universal vibration apparatus experiment. Okay, so I hope you understand this second experiment. Okay, so here the oscillation takes place on the vertical of the x of the shaft. That is very important here. Okay, so I hope you understand this. Thank you.